Hello, students. You're welcome today. Let's have continuation of our studies. Last time we did on derived units of physical quantities. Okay, let's work on dimension of the same physical quantities we worked about. Okay, you can see it on the board. Let's start from, let's say, number one, area. Okay, let's say speed. Last time, when I'm working on speed, I'm already working on velocity because they have the same formulas and everything. Now, this formula for speed is distance all over time taken, right? Okay, now the unit of distance is in meter. Then the unit of time is seconds, which means it can be written as meter per seconds. Now, this is what we have, but our focus is on their dimension. In their dimension, we will be focusing on mass, length, time, and any other one that may come in. But they will all be in capital letters. Okay, now, here, this mass, this is for mass. This meter is not a mass, it's the unit of length. So here, the dimension of this very unit will come on mass is for length. I have my L. So what is time? S raised to power minus 1 represent time. So which means length per time. So this becomes the dimension of speed. Now let's talk about acceleration. Acceleration is velocity all over time taken. Okay, velocity is already given on the board, which is meter per seconds over seconds. So if you take it up, it become meter per second square. Here, based on this, we are going to use length and time. Length for meter is for length. The unit of liter, the dimension of meter is length, while the dimension of second square is time square. So which means length per time square. So number 3, let's talk about force. Force or weight. Okay. When we talk about force, we are also talking about weight because force, the formula for force is product of mass and acceleration. So our mass, the derived unit of mass, of course, is kilogram. The unit of mass is kilogram. Acceleration, derived unit of acceleration is meter per second square. Okay. Then what will be the dimension of mass? Then that is when M comes in, capital M. Capital M. Then M, this M here is meter, which is for length. Then T raised to power minus 2. So that becomes the dimension of force. So if we talk about weight, okay, for weight, the weight of an object is also the product of mass times acceleration. But here it's acceleration due to gravity. So we are going to have it as same thing as kilogram meter per second square. And also MLT raised to power minus 2. Same thing. If we talk about, let's say, pressure. Okay, let's talk about work. Work. What is formula for work? Work done is a product of force times distance. Okay. Now, what is force? Force is on a board. The force is kilogram. Unit of force is kilogram meter per second square. Then times meter, right? Times S. And the unit of this distance here is meter, which is times meter. It will give you kilogram meter square per second square, right? So if I say this times this, it will give us kilogram meter square per second square. So the dimension of this now will be M, okay, L raised to power 2 and T raised to power minus 2. Okay, now let's talk about energy. One of the energy, which is kinetic energy. Kinetic energy, the formula for kinetic energy is half of mv square. Now, in working with units, we don't regard the constant. Half is the constant of this, so we disregard this to work on mass because it's not a quantity, it's not a physical quantity, it's a number. So we are going to, the unit of mass here is what? Kilogram. The unit of velocity, what's the unit of velocity? Meter per second square. Okay, sorry, meter per second. But this velocity is squared, right? Is squared. So definitely it will give us kilogram meter. If I open this bracket, I have meter square per second square, because 2 times minus 1 is minus 2, which means the dimension of kinetic energy is mass, okay, then L raised to power 2, then time raised to power minus 2. So now what do we talk about again? Let's talk about potential energy. Potential energy is the product of mass, acceleration due to gravity, and height. So when we have this, what is the unit of mass? Kilogram. What's the unit of acceleration due to gravity, which is meter per second square? Okay, times height. Height is another times meter. So when meter come here, you also have kilogram meter square per second square. So kilogram meter square per second square. The dimension now will be kilogram is for mass, L square, then T raised to power minus 2. So what do we have to observe here? When you take very good observation here, you find out that the unit that work done, kinetic energy and potential energy all have the same derived unit and the same dimension. Good. Now let's talk about, let's say, pressure. Okay, number 6, pressure. The formula for pressure is what? Force. Force over area, right? Good. Now, what is force? The unit of force is kilogram meter per second square. Then our area is meter square, right? Or meter times meter. M, we cancel one M. So I will have it as, the remaining one will now be kilogram. When M move up, it becomes per meter, then per second square. Okay, so it will give me kilogram per meter per second square. So if I clean this thing to write it well, I will have it as kilogram per meter per second square. Okay, as the unit of what? Pressure. So what will be the dimension? The dimension here we are going to work in as mass. The meter is for length per time square. Now, what about Young modulus? Okay, let's talk about Young modulus. Young modulus is given to us as the ratio of tensile stress all over tensile strain. What is tensile stress? Force over area. What is tensile strain? Extension over length. Which means I can also write it as force over area times, okay, times length over extension, right? Okay. Now, let's bring out the units. What is the unit of force? Kilogram meter per second square times length, which is meter. A unit of area is meter times meter, while the unit of extension is what? Meter. So meter, we cancel meter here. 1 meter, we cancel 1 meter here. What remains? Per meter, kilogram per meter per second square, right? So I can possibly write it as kilogram per meter per second square. Okay, if I bring that, so the dimension will be m l per length and per time square. So what do we also observe again? The dimension of pressure and the dimension of Young modulus, they are same. Okay, please, why am I taking recognizance of all this? Is because in JAM will ask you which of these have same dimension, okay, or same derived unit. Okay, you should know that. Okay, for instance, if I talk of work, kinetic energy, and potential energy, we all know that the standard unit of all is joule. So standard unit of work, all these three is joule, but they may not give you to you. They may not give you this joule. So if they are asking based on derived units, and their dimension. So you should be able to know which one you are working with. So I want you to do this for me and drop your answer in the comment section. That is impulse, and momentum. Okay, please work out this and give me their units and their dimension. Then we'll meet again to share. Okay, please like this video, subscribe, and turn on your notification button so that you can get more of our videos. Thank you.